Okay guys, before we get into it, we're going to have a couple of tutorials on the Arduino. I don't know how many this is. I think I might start breaking up the electronics from the Arduino. I don't want to do that because, you know, I really feel you need an education in both to accomplish many things. The Arduino actually was made so that people with less an understanding could do some amazing things too, but you can even do more amazing things if you have an understanding of both. So I'm probably going to divide these up, start doing an Arduino and electronics, just because this series is going to take us through more than a couple of videos. That said, let's get into it. You'll notice this board with a whole bunch of stuff here. We have, now I've divided this board, except for these pieces up here, into input, our Arduinos, and some output or control. So that's basically what an Arduino is. You have input, you know, sensors, whether they're digital or analog or a button or whatever it is, and we're going to go through some of these. I'm going to show you all these. I'm going to show you these, and then I'm going to show you these, and then we're going to start with going through some of the inputs, from basic buttons, on-off buttons, to analog joysticks, to infrared sensors, to PIR motion detectors, to sonic sensors, to voice modules. But anyways, okay, so we have it broken up into two. We have input and output, and these are the microcontrollers themselves, as well as some communications, ways to communicate with the microcontrollers. I also have part of input and output is communications. You have communications in, you have communications out. So I put a couple of communications devices on both sides of this. So anyways, let's step through what we have for some of our inputs. And like I said, this is just some. There's such a wide variety of inputs that I couldn't have them all here. I probably couldn't afford them all. But I have the ones that I use or that I'm going to use in projects. And I have them here. So let's start reviewing that. First let's start off with these couple of resistors here. I have them under input only because these are 10K resistors, and as you know from our Arduino, our last Arduino tutorial, that, you know, these come in handy as pull up or pull down resistors, and we've used them in the pull down resistor capacity once already. Okay, these here, this is, good thing I have my flashlight. Okay. This here is a temperature sensor. This here is a button. We consider it on the input because we're putting input in. These are some bigger buttons. This is a joystick with also the ability as a button, and you see if I can show you that right now. See that little button there? There's actually a button when I press down on the joystick. It presses that little button. And of course we've got the input and output for our joystick. And I'm going to be doing processing. We're going to do some games. Well, maybe that's a little clearer. And we're actually going to create our own joysticks, and we're going to use many sensors to interface with programs. These are smaller joysticks, push button and directional, just some smaller joysticks. This is a PIR motion sensor. See lots of electronics on that little baby. We'll be working with him. We're gonna go through the data sheets of almost each and every one of these. for inputs, and then we're going to go for, and we're going to combine them, we're going to start to combine them with outputs. What else do we have here? We have a potentiometer. That's an input. You know, depending on what you're doing is how much the analog is receiving. Analog pin is receiving. What else do we got? Hall effect sensors. Hall effect sensors are great. They're actually magnetic sensors. Now they're not like a compass. We got a compass module here too. These guys are really tiny. And you notice I always try to keep all these things separate because they have the same packages, and sometimes trying to read these things is, I won't say impossible, but it's difficult. So you notice I keep it in a little pack called Hall effect sensors. Well, Hall effect sensors detect magnetic fields. And of course this is a neodymium rare earth magnet, very powerful magnet. We'll be dealing with these guys too. He's part of the inputs. This is, I wish I had better lighting here. This is a NPN silicone infrared photo transistor, and it looks like an LED. You got to keep these in their packages. And of course on the back you have the data sheet. And see what I mean about how closely this ties in with electronics? You have your collector and your emitter, which we know from our NPN, and this is actually the base. It detects light. So specifically infrared light, but you could use like red lasers with this. But like I said, it looks just like an LED. You know, and on our, actually these guys, okay, these are our output because we transmit a laser light and receive it on the other end. These are just some cheap laser pointers for $1.99 that I took apart that we can use in our projects. And those can be used with these NPNs here. Okay, we just mentioned infrared. Here is, again, these are infrared emitter and detector. Once again, the data sheet's on the back of these things, and as we use these, we will refer to these data sheets. And so we might need more than just those 10K resistors, because, you know, if we're feeding 5 volts to our infrared LED, it might be too much. Let me see, standard voltage, 5 volts, maximum voltage. So we'll go through the data sheets. So this is package of both the detectors, infrared detectors and emitters, and it looks like it's just the same thing. It looks like it's got the base. It looks like a photo transistor. So I believe the white ones are actually the detectors, just a photo transistor. We have this guy here. This is, we've reviewed this in one of our videos. This is actually a sonic detector. It uses sound output, and you know, once again, it comes with a data sheet for all its pinouts. And let's see, can we make these out? And we'll review that. I have a couple of them here. We have temperature sensors. I think I mentioned temperature sensors. And if you notice, they all come in these same packages. So, like I said, you really have to keep these things separate and keep your data sheets for these things. I have a Parallax Say It module with voice recognition, 30 commands. And based on what you say, the output, then you could go to the Arduino or the basic stamp. We're going to be using Arduino. I prefer the open source. And you know, that is another input. You know, what we would do with that after as an output depends on, I guess, how we programmed and what we were saying. I think I went over simple buttons. You know, simple buttons for. What else do we have here? Hall effect sensors. This guy right here, this is a recent one that I picked up. This is actually a clock module, a highly accurate clock module. And we'll actually use this as well. So we have all these different, okay, we went through the emitter collector for infrared. Well, they have them in combinations already. Like this one, sorry about the horrible lighting conditions, but this one here is infrared. You can call it a detector, you know, a distance measurement detector, I guess. And this one has a narrower beam, and it goes further than this one that has, you know, a wider beam and a shorter distance. And when you buy these guys, you got to make sure sometimes they come with the connectors, sometimes they don't. The connectors like this, you don't want to have to start soldering wires in there or get it here and realize you have to wait for your connector. So this is basically, that is what I just showed you, is this in a nice simple package. Okay, so we have, I think you got the idea for the inputs. Another couple of things I just want to mention. These are very handy. I have both the bent ones and straight ones, and as well as these input rails. These are going to be very handy for our projects. And I get them at SparkFun. Also, on input, these are both input and output. We have Ethernet. These are export modules, and they'll have, they can do DHCP. They could, I have what is it? WizNet, which I have for static IP for the plant. I'll include a little video on the plant. Because the simplest of the input sensors is just 2 wires, and that's what we have for our water detection for our plant. We also have these XB modules, which are for wireless transmitters, and this is the XB Pro series. I believe this is supposed to be good up to 1 mile. If you got a project that calls for 1 mile, a transmitter that'll go 1 mile, you don't want this. You want the next one up, probably the one that says 40 miles, because we've lost signal even with the 40-mile ones when it's in between a building. So this is a line of sight under lab conditions, so you're not going to get that. But these come in models that go from, they're mostly 900 megahertz, which in the US is the open standard that can be used by anybody without having a license. And these come in models from, I think, 100 to 300 feet to 40 miles in range. And the 40-mile ones are a lot bigger than this. I'd have to say like 4 times as big. And on this here, you're going to notice, I'm going to take this apart right now. We have our XB. You actually get this when you order the XB. This is the XB here. And then this is a shield that helps you plug it into your projects. So that's our input. Now we have an array of Arduinos here. I believe in some of our videos you saw this very, very small one, which is just as powerful as this one. You know, except you can't get the shields and stuff for this. You actually have to build it from scratch, which we're going to do for a lot of our stuff. But some people like to get up and running with the shield. Oh, another input I don't have on me here is a little GPS module, which is awesome for input. If you want to make like an autonomous robot, like a boat or even an autonomous ground vehicle that can find its way around, they have GPS modules. So this is another. Now this guy actually takes, this is another Arduino. I believe it has a 328 chip in it. It's the Arduino FIO, which you don't need. You can actually connect this XB directly to this. It has a connection for the XB right on the back of it. You'll, I don't know if you can see through the package there. I don't want to open it up right now. So you program your you program your Arduino and you hook up your wireless, and boom, you've got instant wireless for your Arduino. So many flavors for many different things, many different projects. You know, you need to understand what there is out there and what we have, and then you can determine what your needs are for your projects. Okay, we have all these Arduinos. We have an Arduino Mega. This is a lot of pins. They don't have a lot of shields for this right now, but there's a lot of, this is 54 digital pins, I believe. I see 15 analog pins. We've got a whole array of communication pins, a whole array of pulse width modulation pins. So this is the bad boy. Okay, now connecting our Arduinos to power, you can either plug it in, you know, to a power receptacle, 9 volt. It'll actually do up to 12. It needs to be regulated 12 volt. If if it's too high, you'll blow your Arduino. I recommend using 9 volt input into this. But if we wanted, say, 9 volt, you know, we wanted our project to be, you know, battery operated or solar powered, we'll actually do a solar powered one. We can actually, you can either get a connector that has this connector to a 9 volt battery, and this will plug into your Arduino. See, just like that, and then your Arduino will run off the 9 volt battery. These little ones, it's a more difficult project. You know, we got to build a 5 volt regulator, and actually it could take 9 volts in the raw pin in there. Or you could build your own from this here. See this here? See, you solder those connections there for these leads. And that would plug right into there, just like that, and you'd run off your 9 volt battery. Like I said, you can buy them pre-made, so you know you don't have to do it. I have a bunch of these for the power, for the breadboards, and so I have a bunch of these connectors in case I want to convert them. Okay, so that is our input, and this is our control. You know, this is our brains. This is where we decide what to do, and then we have our output. Now, our output takes many forms. These are just a few. Once again, we can output to Ethernet or to our wireless. Now, this is, like I said, 900 megahertz. You can actually get modules that'll do 802.11 BGN for, you know, I don't want to call it wireless Ethernet, but for your standard wireless communications with your BGN routers, this is actually 900 megahertz. You would go from XB to XB. You could actually have a whole sensor net with these guys everywhere. You can put them all over the place. We have output, we have piezo buzzers. Now these don't just give power and buzz. You've actually got to use pulse width modulation to cause the power fluctuations to go on and off for you to actually hear these guys. But there are other buzzers you can get. This buzzer here, you would just put power to it, and it will run on 2 to 24 volt DC. You know, this is just a little tiny data sheet for it, I guess. And this will just, you don't have to worry about pulse width modulation, and it's actually a lot louder, a buzzer. You know, depending on what you do, what your application is. Once again, we have a NPN silicone infrared photo transistor. We have a couple of them. There's the data sheet on the back. You see the collector, the emitter, and where the light comes in is actually the base. We have a Darlington transistor. PNPs and NPNs are transistors. They come in many different flavors. This is a Darlington transistor. We'll use that with motors. We have a N-channel MOSFET. You know, these get bigger. So we're starting to control more and more power with these guys. And electronics will review op amps and stuff like that, but amplification and oscillation. But this is an N-channel MOSFET. We have a high power fast switch high speed NPN. So, you know, if we want to amplify a signal, we would use this. We also have small LCDs that you can hook up to the Arduino to get output in the form of, you know, English or whatever language you want. So you get actual feedback via words and characters and symbols. We have larger LCDs with touch screens, so this can be an input and output device. And actually, Adafruit, L'Amour, Lady Ada actually has a library for the Arduino for these screens. You have 7-segment displays. This is a big 7-segment display. It's huge. You know, they come in all shapes, sizes, and colors. This is actually a common anode. I recommend the common cathode. Remember we reviewed this in our last video, and it's, if you're not watching the electronics videos and you're only watching the Arduino, common anode means you supply power to it, and then you have to, so you supply a single power source, and then you have to pull low, ground, out all the pins when you want different lights to light up. So I recommend common cathode, which is you have a common ground for everything, and then you supply power to the pins to light things up. I mean, I guess it depends on your taste and your project, but I'm going with what I recommend. We have common LEDs. Remember I mentioned to you, this is when we mentioned the, I guess it's the light's okay without the flashlight. Sorry about that, guys. It's probably been annoying, but this guy here, that longest pin there, you'll see, is a common cathode. I mean, yeah, common cathode. So that is the ground, and then there's red, green, and blue. And if you use pulse width modulation, you can have, you know, a couple of million colors from 0 to 255 on the Arduino. So this is capable of producing many, many colors with the red, green, and blue by using pulse width modulation pins. So it's an analog write, I believe, for pulse width modulation. And by supplying, you know, turning it off and on quickly determines the brightness of each of the colors, and we'll be using these. Now these here, these are a little different. Let's say you've got some kind of temperature sensor going on. So for your output, now this is many LEDs. Now we can use these on just digital pins and just light them up as the temperature starts to increase. And these come in red, green, blue, yellow. Or we could use pulse width modulation so that each LED slowly increases till it's full brightness, and then we go to the next LED and that slowly increases. But we'll be doing that with these. These are actually neat. If you wanted to make your own, say, you know, being a sci-fi fan, tricorder, your own Star Trek tricorder, you would have your sensors, and you could actually build one. You'd have a project case, and these would be your indicators for the amount of feedback your sensors are getting. They're actually a neat little thing. We have a speaker for output. 1 over power. These little laser pointers, you would use a, they require 4.5 volts. I'm not sure about the milliamps. I don't know if a digital pin could power this or not. I'll have to check that out. I believe when we reviewed it was 40 milliamps on the digital pin. So I'll have to see what these are. But if not, you would use an NPN. You'd want a fast switching NPN if we were doing like communication. Say we could actually transmit serial communication between our Arduinos or even on our PC using these simple laser pointers that simple laser pointer and infrared phototransistor. So on either end we would have laser pointers and phototransistors, and you could actually communicate back. And if you use some of our more powerful lasers that you've seen in my electronics vlog, which I haven't done one in a while, I need to do one of those as well. But you'll notice we have much more powerful that you could actually do this over miles. You could have your communications. Just another buzzer. Oh, I almost left out one of the most important controls that we're going to go over, and one of the first controls I think we're going to do. Now, like I said, these digital pins are 5 volt, 40 milliamp output. But you know, we've got all these temperature and humidity. Oh, I forgot that. We actually have here for input. This is a compass module, so we can do compass. We can do, this is temperature and humidity sensor. Well, why do we want to sense the temperature and the humidity? Maybe we want to build our own, I mean, you could easily buy one, but you could build your own, you could computer control your house, say, with, build your own thermostat. That's what I was going to say, sorry. Build your own thermostat where, you know, you're detecting the temperature and then you want to control like the air conditioning. Now that's a lot of power to control air conditioning, but we can do that, and I'm going to show you how to do that, and I'm going to recommend that you don't, because dealing with AC is very difficult and dangerous. So I'm going to show you how to do it, and I'd recommend that you don't. But I've done it myself, but I do it at my own risk. So if you're going to do it, you need to do it at your own risk. So we have 2 what's called relays here, and this is a smaller relay, this first one, and I'll hold it up. This one can control 5 amps up to 250 volt AC. It can do 5 amps up to 30 volt DC. So, and what this is, think of it, this is an on-off switch for greater power. So that we're controlling it with our Arduino. Our 5 volt digital pin can control 30 volt DC 5 amp or up to 5 amp 250 volt AC. So this one little tiny one can control 250 volt 5 amps. So that's a lot of power, but still, that's maybe not an air conditioner. So we can kick it up, we can bump it up a notch. Now, this is the one I use to control the water pump on my plant. I have a plant, I don't know if I've showed you in a previous video, that waters itself. I could also water it over the internet. We're actually going to redo that project so that you guys can see how to do that. So, and I use the small one for that. But if you wanted to control an air conditioner or something, we have this guy can do from 5 volt DC to for the switch, he can control 30 amps up to 240 volt AC. So 30 amps, 240 volt AC just from our little 5 volt Arduino control. And we're actually going to do that. And when I did it, when I did it with this one, what I did was I took the water pump cord and I took the power from that. There's 3 lines in the AC, and I took the power from that and I put it through here. What I should have done is did it on an extension cord. That way you can control anything. And when we do it, we're going to use an extension cord. And that way anything we plug into it, we can control. So basically, we can control AC, we can control DC, we can control motors, we can make robots. I don't have many motors here. Here's a vibration motor. These are little vibration motors. I have other motors around, servos, stepper motors, regular DC motors. We're going to cover all those. And I think, let me make sure. So we've got our Ethernet, our wireless. I went over PZO buzzers, LEDs for output, all kinds of PNPs and NPNs, screens. So basically what we have is we have input, control, output. So we have input coming in, then brains decide what to do with the output, either displays, turn things on off. So we can build autonomous robots. Oh, there's one thing I didn't mention that we're going to be doing. We're going to be using processing for it. And we can take the data received here and actually display it on the computer. We can have the computer communicating with our microcontrollers as well. So, and we could do that many ways. We could do that with a FIDI cable. We can do it with the microcontroller plugged into it. We can actually plug in one of these wireless Zigbees into the computer, and the computer would power it, and it would receive information, and we would have one of these guys connected to our microcontroller somewhere else in the house and transmit back that information to our computer. And then from the computer we could do different things with it. So yes, the computer is I forgot, not only do we have these brains in control, but we can actually refer back to more powerful brains in control, the computer, to make decisions and then send it back to the Arduino, which can then communicate to the output sources. You can computerize, just with the information here, you'll receive here, you can computerize your whole home. Lights, air conditioning, even have motors for your curtains to open and close, you know, have them automatically close at night, open during the day to warm the place in the winter, or have them closed during the day to when you're running the air conditioner. In the summer, to, you know, so you're not wasting. You can make it more green. I know that's the politically correct term right now. Okay, so I think now it's time for us to get to it. What we're going to do is we're going to start working with some of these inputs, and some of these I haven't used yet. You notice this package is not even open. So we're going to learn together. We're going to get some of these things up and running, and we're going to get them inputting into our Arduino and giving us information, giving us feedback through the serial port. So I've been thinking about how to actually conduct these tutorials, and I didn't know whether I should take one of these, this, and then have an output, or if I should review all the inputs, see them, and then, you know, review how to control. I think what I've decided to do was review the inputs so that, you know, we'll get some of these inputs up and running, and we'll get input into our controller. Then we'll work on some of the outputs, you know, maybe using one of the inputs. We'll use some of these outputs so that you can, you know, see how to output from the control, control, AC, DC, have the lights come up. And then, I think once we do that, then we'll start doing individual projects where we have, we have our plant sensor. We have just a couple of wires and stainless steel screws for the water sensor. Going into the microcontroller where it says, okay, it keeps track of the how much water the plant has, or the moisture in the soil that the plant has, and it waits for me to communicate via Ethernet. We create a little web server on here, and where I can water the plant, and it's just a few lines of code. It's nothing very difficult. Where I can communicate and then have the pump water the plant, or I can have the plant water itself if it gets too dry. And it's actually a good project because you have to have a lot of fail-safes in here. Otherwise, you're going to flood your plant and flood your place. So you have to have adjustments in your code to make sure, if the sensor accidentally got unplugged, it's reading 0. It's constantly trying to water your plant. So we've got to include a lot of fail-safes so we don't flood our place if we want to have the plant water itself. It's actually not the plant watering itself, but I like the sound of that, so that's what I'm going to say. It's actually the Arduino turning on the pump when it detects that the moisture in the soil is just way too low, and I've forgotten too long. That's just a nice feature to have, but you need a lot of fail-safes. And so it'll get you into that thinking that, about, this project. What do I need to do for this project? If I'm not there to monitor it all the time, bad things can happen. So you've got to program your code so that you reduce those risks, because you're always going to have some element of risk, but you need to reduce them as much as possible. Anyways, I hope you've enjoyed this brief overview. We're going to start working on some of the inputs now, and I don't know whether it's going to be another video. It depends on how long this is. I might just post this video, and then the next one we start working on the inputs. And we'll be using the Uno. Well, you'll be using the Uno. This is the equivalent to the Uno. Same exact thing. It has different FIDI, USB, and some things, but for all intents and purposes, it's set up the same. Same pulse width modulations. All the programming will work identically on both of these. Both the Uno and the Demulev. And I apologize to anybody from Italy, made in Italy, for any mispronunciations. Okay, I think that's it. Let's get to it.